Okay, yeah. Okay. Hello, everyone. Welcome to this session. Um, okay, so this session is a bit theoretical, more than the previous ones. It's gonna be more like about the regulations that we should follow while building a chatbot. So, in our last session, we touched briefly on something very important, which is the idea that behind every response that chatbot gives, there is something deeper shaping it. We mentioned it as a hint, but today we will go further and look at it directly. So far, we've been studying the chatbot from the outside. We tested how fluent it sounds, how accurate it is, and how fair or culturally aware its responses can be. We treated it as a black box. Um, so, um, so we could see what comes out, but not what happened inside this black box. Now it's time to open it and look at what truly drives the system, which is the most important thing in life cycle of the chatbot, the data that it was trained on. So everything we've discussed so far connects back to that one source, which is a biased answer comes from biased data, just like the garbage in, garbage out principle we talked about in the previous sessions. An inaccurate output comes from poor or incomplete data. A system that fails to handle a real world situation usually learned from the data that didn't reflect real world diversity. And that also, we talked about it when we were talking about the cultural norms that the chatbot be must know. Okay, so think um, think of it like this. If a student studies only one type of example, they will do well with that type, but will struggle when something new appears. The chatbot works the same way. Its performance depends entirely on the variety and quality of what has learned from. So in this session, we are shifting our focus. We're not just testing how the chatbot performs anymore. We are examining why it performs that way. By understanding the data and its content and the quality and the limits, we begin to understand. After that, we will begin to understand the chatbot's mind itself. Okay. So up until now, we've been observing the symptoms, which are the visible issues like bias, inaccuracy, or inconsistency. But today we move from observing symptoms to diagnosing the disease. We will study the root cause behind these behaviors, which is the quality of the data itself. To do that, we will use a structured framework that breaks data quality into 7 key dimensions, which are accuracy, completeness, consistency, relevance, diversity, timeliness, and cleanliness. Each of these dimensions actually tell us something different about how reliable and useful the data can be. We will look at what each one means and how it can be measured and what happens when it fails. For example, when accuracy breaks down, let's say in a medical chatbot can give incorrect advice. When diversity is missing, bias appears from that, as we discussed in session 5. When cleanliness is neglected, the system becomes unstable or unreliable, something we connected to. Um, also, we have robustness, which we talked about back in session 6. We will also classify the different kinds of data that feed the chatbot, from real user conversations to structured databases, and even synthetic or generated data. Each of these plays actually a unique role, and each brings its own risks and challenges. The main idea behind this session is prevention before cure. Instead of fixing problems after the system fails, we learn how to build strong foundation from the start by understanding these 7 dimensions. After that, after understanding the dimensions, we gain the tools to assess and improve the raw material that makes up a chatbot's intelligence. In short, today we are learning how to diagnose and strengthen the very core of the system, the data that defines everything it can and cannot do. Okay, so, all right. Let's move and look at the main framework that we will be using to evaluate data quality. To make our analysis more structured, we will rely on something called the DAMA framework. DAMA stands for the Data Management Association International. It's a professional organization that's been around since the 1980s, and it's one of the main global authorities on data management practices. DAM's goal is to define standards and best practices for how data should be collected, stored, and maintained. Now, in our context, we're not using the full DAMA model. We are just adapting its ideas to fit how chatbot learn and perform. The DAMA framework gives us a systematic way to measure data quality, and we will do that by looking at the 7 key dimensions. These keys act like a checklist to help us see whether a data set is truly reliable or not. Let's go through them together, okay? So first we've got accuracy. So this means the data should be correct and reflect reality. If your dataset says that Tokyo is in China, that's inaccurate, and the chatbot will repeat that error confidently. The second one is completeness. And this checks whether we have enough data to cover the topic properly. Imagine training a travel chatbot, but all the data that comes from Europe, just Europe. It might give great advices for Paris or Rome, but it'll have no clue about Nairobi or Cuba or any other elsewhere than Europe. So that's a completeness issue. Next, we have consistency. Second. Okay, so data should agree with itself and with other sources. If one data set says a product costs $20 and another says 25, the inconsistency can cause the chatbot to give conflict answers. So consistency must be followed by giving the same output for each input for every dataset that has been used in this chat. Next, we've got relevance. I'm just going through them quickly. We will see each one of them thoroughly through this session. So relevance. So even if the data is correct and consistent, it still needs to be suitable for the task. For instance, a medical chatbot doesn't need movie reviews in the training set. Relevance keeps the system focused on its purpose. So it's not just being generalized, also to be uh, focusing on the main thing that the chatbot is serving. Then we've got diversity. This one that we've talked about many times. This one asks whether the data represents a wide range of users, languages, scenarios. The chatbot that's trained that is trained only on English from the US will struggle with accents and idioms, just as we said before in the cultural session, the one where we talked about a chatbot um, should be trained on wide range of cultures, languages, accents, etc. Also, we've got timeliness or called freshness. This checks whether the data is up to date. So, a financial chatbot that is trained on data that, from 2015 won't handle modern regulations or market conditions very well. So, time changes, so does the chatbot has to change along with it, or the data that's been given to the chatbot. Finally, we've got cleanliness or purity. So this focuses on removing noise and duplicates and formatting issues. Think of it like cleaning your ingredients before cooking. Messy input will always lead to messy output. That's a general principle. So yeah, these seven dimensions come from a long tradition of data management practices, but they're now adapted for the AI era. They help us assess whether the foundation of a chatbot's intelligence is strong or fragile. Okay. After we learned to evaluate data quality, we need to understand what kinds of data we're actually working with inside the chatbot system. Because before we can measure or improve data, we have to know what forms it takes and what role each one plays in the chatbot's life cycle. In most chatbot systems, there are three main types of data: the conversational data, the knowledge bases, and the synthetic data. Let's look at each one. So the first one and the most important one, the conversational data. This is the raw material that teaches a chatbot how to understand and respond to human languages. Now I'm talking about the way that we type our prompt into the chatbot. So that is the human language. So when you tell the chatbot, for example, book, okay, this won't work. Second. Book a flight on Monday. For example, if this was the prompt that you give for a chatbot, so it won't understand it like you understand this sentence. It won't just understand the natural language that you're talking that you're talking with. It has to be converted into some set of vectors that the chatbot can understand, which is the language of the numbers or like vectors. So what we use to train the chatbots are the natural languages, like every post that has been posted on Reddit, Facebook, blogs on the internet, etc. All of these are natural language sentences. So the conversational data is about understanding the natural language or natural language understanding, um, in brackets NLU. Models can see this data that consists of user utterance, what people actually say, along with their corresponding intents and entities. So if we can revise the intents and entities, so what could this intent be for this sentence? It's booking flight. For example, the chatbot can say booking flight. This is the intent for this sentence. And what are the entities? For example, this, so let's say this here, Monday is the date or the day. There is one entity here, we could say. Let's say to Dubai, for example. If we said to Dubai, Dubai would be the destination. So yeah, these are the intent and the entities of this sentence. So for this kind of data, sorry, for this kind of um, data training or database, the conversational data, it sees the it sees these natural languages sentences and split them into both intents and entities. The quality of the data here is critical. If the utterances and intents aren't labeled properly, so let's say if the data set that has been given to this chatbot is labeled incorrectly, so if this one hasn't been the correct label for this sentence, let's say it was booking a bus, for example, or like booking a meeting, for example. This is a wrong label for this sentence. So the chatbot might struggle here to understand the intent for more sentences that looks like this one. So this type of data is directly tied to the chatbot's accuracy in understanding human inputs. Okay, so the second type is knowledge bases, or KBs. These are structured collections of factual information, things that chatbot relies on to answer questions correctly. A knowledge base might look like a table of store opening hours, a product catalog, or even a set of policy documents. Let's give an example here. A banking chatbot might pull information from a table showing branch hours, or a text document explaining the return policy for that. When the data in the knowledge base is complete and accurate, the chatbot provides correct and reliable answers. But if the data is outdated or inconsistent, even the smartest chatbot will give the wrong information. This is especially critical in specialized domains like healthcare or finance, which we discussed back in session 4. Okay, so the third type here is synthetic data. This is data generated automatically, often using other language models to real simulate real user interactions. It's especially useful when we don't have enough real data. For example, when working with low resource languages or rare use cases. Let's say we use GPT-4 to create 100 different ways of asking, what is my balance? So if we generate multiple sentences, that means this one, that's synthetic data. When used carefully, synthetic data can improve the chatbot's diversity and robustness, making it more adaptable to new situations. Something we talked about in session 6. But it also comes with a risk. Since the data is generated by another model, it can carry over existing biases or introduce new ones. So that would be a real bug here or issue. So to summarize this whole thing, the conversational data teaches the chatbot how to understand humans. The knowledge bases give the facts that the chatbot needs to answer correctly. The synthetic data fills the gaps and strengthens performance where real data is missing. So together, three from the core of the chatbot's learning environment: And just like any system, the quality of its output depends on the quality of every piece of input it receives. Okay. So let's start breaking down the first of the 7 dimensions, which is accuracy. Now, when we talk about accuracy in data, what we really mean is how close the data is to the truth. Think of it as asking one simple question: does the data actually match reality? Let's look at how this plays out inside a chatbot. In conversational data, accuracy means that each user utterance is correctly labeled. For example, if someone says, "When does the airport branch open?" the intent should be labeled as "check opening hours." So that's the correct answer. Um, and airport should be tagged as the branch location. If those labels are wrong, the chatbot will completely misunderstand what the user actually wants. But in knowledge bases, accuracy means that the factual information stored inside the system actually matches real world facts. So if the database says that the airport branch closes at 6 p.m., but in reality it closes at 8 p.m., that's an accuracy problem. And when users depend on that information, even a small mistake like that can cause confusion and frustration. Now, how do we measure accuracy? There are a few simple but effective ways. The first one is human review, the most obvious one, where we take a sample of data and compare it manually to a trusted source of truth. The second one is double checking, where two animators label the same data independently. If their label don't match, that tells us accuracy is low. The third is validation against external rules or databases, like checking addresses or business names against verified lists. So in real AI model projects, the datasets are actually splitted into 2 sets. The first one is training dataset, or train set. The second one is the test set. So in real AI models, the first one is training the data sets where the labels are given. So in the training set, when the data is given to the AI model, it is given with the labels, like when we talked about booking a flight. The intent where we labeled, I want to book a flight, which is booking a flight, is given and introduced to the AI. But while in test set, it's missing. So the AI should be generating it or predicting it. The AI in the test set should predict whether the label is booking a flight, booking a schedule, etc. And then it will compare it with the real set, which the real label is known, but not given to the AI. And that's how we measure accuracy. Um, okay, so when accuracy fails, the consequences are immediate and serious. If conversational data is inaccurate, the chatbot's entire understanding model, the natural language understanding, I mean, becomes faulty. That means it starts misunderstanding users' right from the start. And if inaccuracy exists in the knowledge base, the chatbot will spread false information. In some domains like healthcare or finance, that's not just a small issue, it can be dangerous, very, very dangerous. Think back to what we discussed in session 4 with my colleague on high stakes domains. A medical chatbot giving the wrong drug dosage isn't just making a data error, It's creating a potential real world risk. So accuracy isn't just about clean data, it's about trusting the chatbot. If we can't trust the data, we can't trust the system that was built on top of it. So that's the accuracy. And this one is used in most of the AI models. Okay. So the next one is completeness, the second dimension. Okay. So completeness is all about making sure there are no missing pieces. In simple terms, it's the absence of gaps in the data. Even if the data we have is accurate, it's still a problem if it's incomplete, because the chatbot can only work with what it's given. Let's see what that means in practice. So in conversational data, completeness means that all parts of the user's message are correctly captured. For example, book me a room for 2 people at the Hilton for tomorrow for 2 nights. I'm looking at this example over here. Okay. So to understand this request fully, the system needs to extract every key detail: the number of people, the hotel name, the start date, the duration. If even one of these pieces is missing, the chatbot doesn't really understand the full intent here. In knowledge bases, completeness means having all the necessary details for every entry. So imagine a product database that lists prices for the products, but they forget to include descriptions or even images for half of the items. The chatbot might know a product exists, but it won't be able to explain it or recommend it properly. So how do we measure completeness? There are a few common ways. The null value analysis. This simply means checking how many fields in the databases are empty. A large number of missing values means your data isn't complete. So the datasets are usually in this form. It's a table of columns and rows. So if one column, for example, let's say the images of these products, okay, so if the images are all null, what I mean is null like this. So in the word of datasets, the products can be entered to the chatbot in this way. So this is the columns of the image. If most or many of these rows are shown as null, this is a null value calculation. This one is the measure that we do to measure the completeness. Okay, so the second one is intent coverage analysis. This checks whether there are user intents that don't have any examples in your training data. If people ask something that the model has never seen before, that's a completeness problem as well. So what happens when completeness fails? First, the chatbot may only partially understand what users are saying. It might catch the intent but miss an important detail, forcing to ask unnecessary classification questions like for how many people or what date. That slows the interaction and frustrates users. Secondly, if the knowledge base is incomplete, the chatbot will simply not know how to answer many valid questions. That's when you start hearing the dreaded "I don't know" or "I'm not sure" responses from the chatbot. It's not because the system is bad, it's because its knowledge is incomplete. And I'm sure you've been through this before, with small chatbots from certain companies, certain people. So yeah, okay, let's move on. Okay, the third dimension here is consistency. Consistency means that the data doesn't contradict itself. It's about keeping things stable and uniform across the entire dataset. If the same information appears in two places, it should look the same both times. Let's see what that means in practice. So in conversational data, consistency means that the same utterance is always labeled the same way. For example, if the phrase book flight to Paris, when this phrase is labeled with the intent book flight, it shouldn't later appear labeled as travel request. That kind of inconsistency confuses the model during training. It also applies to entity names. If one part of the dataset uses destination city and other uses city too. I'm talking over here. So if those labels, let's say that they are the um, title of that column. If one is um, called destination city and other is city two, that will lead the chatbot to conflict and doesn't understand that this one actually means this one. Okay. So it also applies to entity names. If one part of the dataset uses, I'm sorry, that one is said. Okay, so consistency is about keeping values aligned across different tables or documents. For instance, if product X costs $10 in one table but shows $12 in another, the chatbot won't know which value to trust, and neither will the user, of course. So to measure consistency, we usually do two main things. One is to use automated validation rules, which are small scripts that search for contradictions. For example, they can scan for the same product listed with different prices. And the second one is review and annotation guidelines. This one is used to make sure that human annotators follow the same rules and naming conversations so that their labels don't conflict, the different annotators. Now, what happens when consistency fails? The model's behavior becomes unpredictable. It might interrupt a sentence correctly one time, then fail to recognize in the next. Even though it's the same input, that's because it learned mixed signals during training. For users, inconsistency breaks trust instantly. If the chatbot gives one answer in the morning and different one later, to the exam to the exact question, people stop believing anything that the chatbot is saying. And we discussed this back in session two. Once user trust is lost, user satisfaction collapse with it. So yeah, consistency is really about stability. It ensures that the chatbot behaves the same way every time. It builds trust and maintain credibility. Credibility through reliable and repeatable behavior. Okay, so next we've got relevance, the fourth dimension. Relevance means the data must fit the purpose of the task. In other words, it's not just about being correct, it's about being useful. Here's the key idea. Data can be 100% accurate and still be completely irrelevant. Think about this example. If we train banking chatbot using Twitter conversations about, let's say, football, The data might be accurate, but I mean, the data is accurate because people really talk about football in Twitter, but it has nothing to do with banking. The chatbot will learn a lot about teams, scores, and absolutely nothing about loans or accounts or anything about the bank. So even in less obvious cases, this happens a lot. So suppose we train a customer service chatbot using formal legal documents. The data is correct, but the language is not. Here we're talking about the natural language or the words, um, the chat. Okay, so I got a notification that my network is slow. Can you hear me? Okay, thank you. Um, okay, so we were saying that the chatbot. Okay, so yeah, in relevance, the chatbot ends up sounding robotic if the real voice or the real words that is supposed to be saying the chatbot is not saying them, so it ends up being robotic or out of touch with actual users. So to measure this one, relevance, I mean, there are two effective approaches. The first one, subject matter expert or SME. Um, for example, actual customer services can read through data samples and tell us if they sound like the conversations they handle every day. The second one is to use vocabulary distribution analysis. This means comparing the words used in the training data with the words real users use. If the chatbot's data and real life conversation look very different, that's a warning sign. So here, when training a model, so let's say we've got this training data set that has been that a chatbot has been training on is being compared with another data set that the AI hasn't seen before, or like the chatbot, it hasn't seen before, and it has the same features. For example, let's say the tone that specific people are talking with, or the dialect that specific people are talking with, etc. It has some features over here and features over here, and then we measure how close that the data, the training data is to the real data from real world users. Okay, so this is vocabulary distribution analysis. But when relevance is poor, the chatbot starts to sound disconnected. It might answer in ways that don't fit the user's questions or even tone. So it fails to understand real users' languages and comes across stiff and unnatural or even useless. So another issue here is performance bias. A model trained on irrelevant data might perform well during testing because um, it's tested on similar and irrelevant samples. But the moment it's deployed in the real world, its performance will drop sharply. So actually, this one has a name. It's called overfitting. When the data is trained so much on, I'm sorry, when the AI or the chatbot is trained heavily on one data set, then it loses any way to understand other data sets, like the real ones that we need this chatbot to understand. So relevance keeps the chatbot grounded in reality. It ensures that the system speaks the same languages as the users and focuses on the right problems, not just any problems. the problems that actually benefit the users. Okay, let's move on. The fifth dimension, diversity. So diversity is about how wide, and this one actually one of the most important dimensions. This one is about how wide and balanced the data is. It measures the data, how the data should represent different users, dialects, phrasing styles, and situations. In simple terms, the data should reflect the real world, not just a small piece of it, the whole one. So this one also direct. I'm sorry. This is also the direct antidote to bias. If we only train one kind of data, the system will only work well for that group and fail for everyone else. The challenge is it's easy to collect data, a lot of data from a single source, or demographic, as we talked before. There are a lot of sources and data of Western side, like English, and the culture that is in the US, or etc. But it's very low from other parts of the world, like in Asia, in Africa, etc. So this one here is a problem, or a challenge, but it's much harder to make it diverse, to go through the whole word of data. So, for example, if a chatbot is trained only on English data from one country, it might perform well here, but it will struggle with other users. There are three main kinds of diversity to look for, which is linguistic diversity, demographic diversity, and scenario diversity. We've talked about many of those before. Let's give them a quick through. So the linguistic diversity means capturing the many ways people can say the same thing. So one person might say, book a flight. Another might say, I need a ticket, etc. So the same intent might varies in different words and in different order of these words in the same sentence. The second one is demographic diversity. It focuses on who the data represents, different ages, genders, regions, cultural backgrounds, etc. So, for example, if the data only includes young urban speakers, the chatbot won't perform equally well for older or rural users. Give me a second. 1 second, please. Okay. So yeah, we were saying the demographic diversity. So yeah, also we've got the scenario diversity. This is about including different kinds of situations, not just the smooth, ideal conversation, what we call a happy path, but also the messy ones, like when users make spelling mistakes, ask unclear questions. Yeah, I mean, this happens a lot. We're human. We make mistakes. So if two letters of one or one word are replaced, the AI should be able to connect it with the nearest or most possible answer or word for this one. It shouldn't just say, "I don't understand. Please re-ask or ask again the question," and you have to do it again and write it and see what was mistaken. This whole scenario is dull and not preferred for users. So yeah, We talked about this one actually in session 6. Um, okay. So to measure diversity, we usually rely on two approaches: the demographic distribution analysis. Also, if user metadata is available and only when it's collected ethically, we check that there isn't a strong skew or toward one group. Also, semantic coverage analysis. Here we use clustering or visualization tools to see whether the utterance cover the whole space of possible questions, or if there are big empty areas or gaps where the chatbot has never seen similar examples. Okay, so when diversity fails, the impact is serious. First, it directly creates bias and discrimination, which we explored in session 5. The chatbot ends up performing well for some users, but poorly for others, often without anyone realizing it. Secondly, we've got the robustness. It weakness the robustness. When the chatbot only sees one kind of phrasing or one kind of situation during training, it easily breaks when faced with something new. So diversity isn't just about fairness; it's about strength, and the diverse the data set is, the more that the chatbot will understand different people and in real words. Okay, let's move on. Okay, so timeliness, or sometimes called freshness. Timeliness is about keeping data up to date. From its name, the word changes constantly. New products are launched, policies are updated, and events happen every single day. If the data does not change with the word, the chatbot quickly becomes outdated. So let's look at this one in context. In conversational data, timeliness means the chatbot should learn from current user behavior and language. People's way of speaking evolves, new slang, new trends, etc. So the chatbot will sound old-fashioned and may fail if it's outdated. In knowledge bases, timeliness means that all factual information like product prices, branch hours, etc., must be current. Outdated ones mislead users. We can measure this timeliness in two ways: the timestamps, easy one, and the drift monitoring. So every record, a record is the row in the dataset. So we've got multiple rows. So in every row or every record, we have got to have a column with a timestamp, which gives the date and the time of this record. Just like if you have used Google Form before, when you generate a Google Sheet from this Google Forms, it automatically has this column along with it. Okay, so the drift monitoring one, automated systems that track performance over time. If accuracy suddenly drops, it often means that the world has changed, but the model hasn't. Okay, so let's talk about when it fails. If timeliness fails, the chatbot becomes unreliable, outdated. The outdated information can be just as harmful as incorrect ones. Imagine a chatbot telling a user that a specific product is in stock when it's been sold for weeks. So this one is misinformation. And over time, the chatbot simply loses relevance. It stops recognizing new terms, new products, new regulations. In other words, it stops living in the same world as its user. So yeah, timeliness is about keeping the system alive and aligned with reality. Okay, the last and final dimension is cleanliness or purity. Cleanliness is about removing noise, errors from the data. In simple terms, it means the data should be free from unnecessary clutter. Things like duplicates, formatting mistakes, junk entries that don't belong here. So let's look at what dirty data actually mean or look like. So there are few common types. The duplicates. This happens when the same record appears multiple times. It might seem harmful, but it can bias the model by making it think that examples is more important than the others. So yeah, it's harmful. Formatting errors. These include inconsistent date formats, extra symbols in numbers, or even leftover HTML tags in text. So small things like this can cause major problems during model training because the model isn't smart. It uses math to see patterns through the data. So if the data is faulty or the data is full of junk and unwanted words, for example, the AI model, so this is the data here, the AI model will be learning all these faulty things and doesn't know that they are faulty because we haven't labeled them as faulty or anything. It just takes what the input is and just acts on it. Okay. Also, we've got the junk data. This is the unwanted content, empty messages, developer test inputs, etc. So to measure and manage cleanliness, we often use automated data profiling tools. These tools scan the dataset to detect duplicates, outliers also, and inconsistent formats. They help us spot issues that would be nearly impossible to find manually. What happens if cleanliness fails? First, training itself can fail. Some formatting errors can cause the entire model to crash or behave unpredictably. Even minor inconsistencies can disrupt how the system learns. Okay, secondly, there is a subtle but important point: if we over clean the data, the model becomes too sheltered. It learns from perfect examples only. Then when it faces real world inputs that are messy or unstructured, like typos, abbreviations, slang, etc., it will struggle, as we discussed in session 6. So this directly reduces robustness. Okay. So cleanliness require balance. The data should be clean enough to train effectively, but not to sanitize, not to I'm sorry, sanitized the data. It stops reflecting how people actually talk and behave. The goal is not perfection; it's realism. Data that's structured, reliable, still human. Okay. So that brings us to the end of today's session. We've gone deep into what really makes a chatbot tick. Its data. If we think of the chatbot as a brain, then data is its nervous system. Every answer, every decision, every smart or silly response it gives comes straight from the data. And as we've seen, data quality isn't just one box to tick. It's web of 7 pieces working together. The whole 7 keys. Each one matters. If even one fails, everything else starts to shake. The chatbot might sound confused, biased, outdated, um, or just plain wrong. So what we did today was move from testing the chatbot to understanding why it behaves the way it does. We're not just observers anymore. We're becoming engineers of quality, because when you get the data right from the start, you don't just fix mistakes, you stop them from ever happening. So take a second to think about this one. If the data is the nervous system, then improving its quality is like giving the chatbot a sharper mind and stronger reflexes. And okay, so next session, we're taking knowledge one. I'm sorry, we're taking knowledge one step further. Now that we know how to build quality data, we will learn how to protect it. We will move into data security, how to keep that data safe, private, and protected. Sorry, from threats. So buckle up. The next part isn't just about making the chat was smarter. It's about making it safe or keeping it safe. Okay. Thank you, everyone. If we got any question, we have like 3 to 5 minutes to answer them. So go ahead. Thank you for listening.